January 14, 2005. Inside a German mission control room, 260 engineers sat in complete silence. They were waiting for a single beep from a machine falling through the atmosphere of a moon 1.2 billion kilometers away. That machine was the Huygens probe, riding along with the Cassini orbiter. Together, they made up a $3.4 billion payload, the heaviest interplanetary spacecraft ever launched. Getting to Saturn took 7 years of complex gravity assists, slingshotting past Venus, Earth, and Jupiter to build enough speed. But during that long coast, a junior engineer running a random test noticed a fatal flaw. As Huygens descended, its relative speed to Cassini would constantly change. This creates a Doppler shift in the radio waves, the exact effect that changes the pitch of a passing ambulance siren. Cassini's receiver couldn't handle that shift. Every piece of data Huygens sent would arrive as completely scrambled noise. To prevent mission loss, engineers spent 4 years recalculating the flight path. By changing the approach angle, they reduced the relative speed between the two craft, allowing the receiver to maintain a lock on the data transmission. When Huygens finally woke up on its descent, it began broadcasting its telemetry on 2 redundant channels, A and B. But thanks to a single missing line of programming code on Cassini's end, channel A never turned on. For exactly 90 minutes, the Huygens probe fell through Titan's atmosphere, capturing images of a world we had never seen. Because of that missing command, half of the most important photographs in the history of astrobiology were lost to the void. But Channel B worked, and the images that made it back to Earth showed a landscape no one expected. As the probe broke through the orange clouds, it revealed dark valleys carving through bright mountain ranges. When Huygens hit the ground, it bounced, slid, and settled on a shoreline covered in smooth, rounded pebbles. Above them sat a complex network of drainage channels and dry riverbeds. These features are clearly carved by flowing liquid, yet the surface temperature here is -179 degrees Celsius. Water is frozen so solid it acts like bedrock. We had found a functioning, active world, identical to Earth in its mechanics, but built out of entirely different, frozen ingredients. To figure out what carved those riverbeds, Cassini spent 13 years scanning Titan from above, piercing the haze to map the moon. It revealed a complete hydrological cycle. In the extreme cold of Titan, methane and ethane, the natural gases we use for stove fuel on Earth, condense. They form clouds, rain down on the surface, and pool into lakes, acting exactly like water does here. This cycle creates massive bodies of liquid. Near the North Pole, Cassini spotted Ontario Locus, a lake with a footprint nearly identical to North America's Lake Ontario. But that's small compared to Kraken Mare. This is a sea of liquid methane so massive, nearly the size of the Black Sea, that the pull of Saturn's gravity generates actual measurable tides across its surface. Because the sun is so weak all the way out at Saturn, evaporation is incredibly slow.
This leads to droughts that last for centuries. But when the atmosphere finally saturates, it unleashes catastrophic flash floods, violently carving out the terrain before the drought returns. Titan proves that planetary mechanics don't require water to function. The flow of rivers, the filling of oceans, and the cycle of rain operate perfectly on materials we consider totally alien. Below this freezing surface, Titan gets even stranger. The moon's icy crust hides cryovolcanoes, but instead of molten rock, they erupt a thick, freezing slush of water mixed with ammonia. This slush is coming from a massive reservoir. 55 kilometers below the ice crust sits a global subsurface ocean containing more liquid water than all the oceans on Earth combined. When cryovolcanoes bring heat up and surface hydrocarbons trickle down, these ingredients mix together. That specific chemical environment closely mirrors the conditions found on Earth 4 billion years ago. Recently, researchers recreating Titan's natural conditions in a lab watched as hydrocarbons formed vesicles. These are small, cell-like bubbles encased in a membrane, the exact structures that housed the very first prebiotic life on our own planet. By combining these organic building blocks with liquid water and internal heat, Titan offers a real-world environment to observe the chemical steps that precede the emergence of life. We can only learn so much from a distance. To sample this chemistry, NASA is sending the Dragonfly mission to take flight in Titan's skies. Currently in its active integration phase, Dragonfly is a massive 8-rotor drone powered by a plutonio generator. It launches in 2028, and when it arrives in 2034, it will be capable of flying hundreds of kilometers. A wheeled rover would struggle to cross Titan's jagged, icy terrain, but with gravity 1/7 of Earth's and a thick atmosphere, sustained flight is highly efficient. Its destination is Selk Crater. Thousands of years ago, a massive impact here melted the water ice, mixing it directly with organic hydrocarbons to form warm pools that stayed liquid for centuries. Dragonfly will land exactly where those pools eventually froze. It will drill into the sediment, hunting for the chemical precursors to biology, searching for the exact step where ordinary molecules organize into something living. Right now, the Huygens probe is resting in a dry riverbed, its battery dead, its camera frosted over. It has sat there 2 decades. Many of the scientists building Dragonfly today will be retired by the time their machine arrives to pick up the baton in 2034, but they know what is at stake. Deep within the sediments of Selk Crater, a self-replicating pattern may be waiting to prove that life is a natural consequence of planetary chemistry, rather than an earthbound anomaly. The origin of life is not a purely abstract question.
The answer might physically exist, perfectly preserved, 1.2 billion kilometers away, and the countdown to retrieve it is already running.